Hi everyone, my name is Giovanna Proença and today we're going to do SQLBolt. If you want to get my solution to these problems and also an ebook on how to become a developer as fast as possible, click on the description below. So the idea of the SQLBolt is to learn SQL with simple interactive exercises. So the idea here is what it's going to work our video. So I'm going to do the exercises, okay? But in each page we have a lot of text to read. So I highly recommend you to, every time that we start a new section, you stop the video, read the web page, and then keep watching the video to understand how we're going to solve the problems, okay? So this is in the introduction to SQL, okay? So I'm just going to read this part because I think this is important. Then you're free to read, okay? I'm going to say again, I highly recommend you to read everything to get all the idea of SQL, okay? Because it's a new language and there's a lot of things to learn, so it's really good to see this website, okay? And also, we're going to use in some moments the documentation W3 Schools for SQL. So if you see here, we have a lot of documentation to see. So don't feel that you are alone because you're not. You have a lot of documentation and these two websites are the best to learn SQL, okay? So what is SQL? SQL, or Structured Query Language, is a language designed to allow both technical and non-technical users query, manipulate, and transform data from a relational database. And due to its simplicity, SQL databases provide safe and scalable storage for millions of website and mobile applications. So SQL is really important because we're basically going to work with database, okay? So let's start our interactive tutorial. It's this part here, okay? We're going to do all of this. And now it's the part that I recommend you to stop the video and read all of this website, okay? And then click the video again and see the solution. So let me highlight some parts. So here, the idea basically is to understand the select and from, okay? So, and a given table of data, the most basic query we could write would be one that selects for a couple columns, properties of the table with all the rows instance. So, one thing that is important to know is that in SQL, we can manipulate the database, okay? So we already know this. And we can use some commands to manipulate this database. For example, select. When we use select, we are selecting the queries that we want to get, okay? So for example, select a query for a specific column. So if I want to grab some columns here, I will select, and then we have to put from to specify which table we're grabbing, okay? We can specify the columns, or we can use a star here, okay, if you want to grab all the columns in the table. So if you want to retrieve absolutely all the columns of the data from a table, we can use the asterisk shorthand in place of listing all the columns named individually. So we have these two ways of grabbing information. Or we can use the asterisk if you want to grab all the columns of the query, or we can specify the columns we want to grab, okay? So let's see the first problem. Exercise. We will be using a database with data about some of Pixar's classic movies for most of our exercises. This first exercise will only involve the movies table, and the default query below currently shows all the properties of each movie. To keep on to the next lesson, alter the query to find the exact information needed for each task. So here, it's the tasks that we have to do to finish this exercise 1, okay? And this is the query that we're going to work. So the table, it's called movies, and we have the column ID, title, director, year, and length minutes, okay? So let's see our first task. So find the title of each film. To find the title of each film, what we're going to do? So we're going to remember here when we want to grab a specific column, we use select, the name of the column, and then we put from my table. So why can we see all the columns in the table in here? Because we're using by now select asterisk from movie. So here we're grabbing all the columns. But now the problem wants us to find the title of each film. So here in select, what we're going to put, the title of each film is in the column title. So here we're going to write title. Okay. So here we did the first task. So you can see here the check icon. Now let's get to the second. Find the director of each movie. So let's see the whole table again. And what's the name of the column that we can grab the director of each movie? It's the column called director. Okay? So we did this next task. Now find the title and the director of each movie. So how are we going to do this? If we see here in the documentation, when we want to select more than one column, we have to use the comma here, okay? So that's what we're going to use. So here we're going to find the title, right? And the director. Okay? So remember, we have to put the same name that appears in the column, okay? The word select, that it's a word that the SQL understands, has to be all in capital, okay? So we have to use all uppercase. From, it's another word that we use in SQL, so that's why we're using all uppercase, okay? So don't forget that. And we have to close our line with a semicolon. Let's see the next problem. So find the title and year of each film. So let's check the whole table again. And what's the name of the column for title? So we already know that it's title, and the year it calls year. So here we're going to do this again, title and year, and we're grabbing all. Now find all the information about each film. And how we grab all information from each film, we use an asterisk. Okay, so we did the first problem. Now let's go to the next one. Now that we're going to the next part, so again, pause the video, read what it's written in here, okay? But I'm going to now explain some parts. So in order to filter certain results from being returned, we need to use a where clause in the query. So where is the word that the SQL understands to get some certain results in the query, okay? The clause is applied to each row of data by checking specific column values to determine whether it should be included in the results or not. So let's check here. To select a query with constraints, here we use the select, okay? So we select as we already know, right? When we are selecting columns, we use the select. We saw in the previous session. So we use select, we put here the column, the name of the columns. We have to use from to specify which table we're grabbing. And then we have this where condition. And in the where condition, we're going to use where, and we're going to set a condition. And if we want to add more conditions or not, we can use and or. It's like the if and else case, okay? So if blah, 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 and we have the and or, and we can put another condition. So more complex clauses can be constructed by joining numbers and or logical keywords. And below are some useful operators that can be used for numerical data. So here these operators are the same as we use when we are writing Python or in C language, okay? We have also the between and end, when we want to put the condition, the number is within range of two values, okay? Not between and number is not within range of two values inclusive. These three, okay, these three that's not. So in, if we want to say that the number exists in a list, or not in when the number does not exist in a list, okay? So to do these exercises, this information, it's okay, but I will say this again. if you want to understand better SQL, so stop the video and watch all of this, okay? So by now, what we're going to do, using the right constraints, find the information we need from the movies table for each task below. So let's do. First thing, we have to find the movie with a row ID of 6. So we want to find the movie with a row ID of 6. So we're going to select all the columns because we want to grab the movie. So it doesn't specify which column he wants us to grab. We already have here from movies, okay? So from, it's where it's the table that we're grabbing, and the name of the table it's movies. And now we're going to use the where clause to grab the movie in the row ID of 6. And how do we use where? We're going to write where, and we're going to set the condition. And what's the condition? So ID of 6. And in here we're going to use the same idea as when we are programming in Python or in C. We're going to use where ID equals 6. Okay, so here we're grabbing the movie with ID equals 6, that is The Incredibles. Now find the movies released in years between 2000 and 2010. So now we're going to use the where again, okay? Let's just see what we have here. So we want to grab the movies released in years between 2000 and 2010. And how are we going to do this? We're going to use this operator, between and, okay? So a SQL example, we're going to use year between 2000 and 2010, okay? This will be our construction. So where year between 2000 and 2010, okay? And remember, we have to use these both words the same way here, okay? And we're grabbing the task, okay? We're grabbing here the movies that are in the range of 2000 and 2010. Now find the movies not released in years between 2000 and 2010. And how are we going to do this? We're going to use the operator not between. So we're going to put here a not word before between, okay? So we're grabbing what it's not between this range. Now find the first 5 Pixar movies and their release year. Now it's a little bit different. So here we have all the Pixar movies, right? But we want to grab the first 5 Pixar movies. And what are the first 5 Pixar movies? As we can see here, our table it's sorted, right? So the first movie was released in 1995, and then we're sorting, we have this all sorted up to 2013, okay? So how are we going to grab the first 5 Pixar movies? We're going to use where, okay, where, and we're going to use the ID as the condition to grab the first 5, okay? So since this is sorted, we're going to use the ID. We have ID 1 and we're going to grab up to ID 5. So ID between 1 and 5. Okay, so we've done this exercise. Let's go to the next one. So I'm going to say this again, and if you want to understand better, you can pause, okay, to read everything. And now I'm going to read some parts. So when writing where clauses with columns containing text data, SQL supports a number of useful operators to do things like case insensitive, string comparison, and wildcard pattern matching. We show a few common text data specific operators below. So we have these specific operators as equals, so case sensitive exact, string comparison, okay? Notice the single bracket, so here we're going to have a case sensitive, okay? So what's case sensitive? It's when we are comparing things and it has to be on the same, it has to be written in the same way as we're using the equals. we have the difference and these curly brackets here, and the case sensitive exact string equality comparison, and like and not like are case insensitive, and they are used for comparison. Okay, this percent here, it's used anywhere in a string to match a sequence of 0 or more characters, only with like or not like. So if you want to grab a specific match of a specific string to match, we have to use like and this percent here, because we know that like and unlike, it's case insensitive, and when we use the percent here, it makes this with case sensitive. Okay, we use this hyphen here, use it anywhere in a string to match a single character, only with like and unlike again. In, if the string exists in a list, and not in if it doesn't exist in a list. Okay, so let's do the exercise. Here's the definition of a query with where clause again. So we already saw this in the previous section, okay? And now we're going to do the question. So first thing is, it's the same table that we were using before, okay? And now we have to find all the Toy Story movies. So how are we going to do this? We want to grab all the Toy Story movies, and we can see that Toy Story has the same name, but just changing the last number that appears. So we have Toy Story 2, Toy Story 3, and 4. The Toy Story 4 doesn't have here because this website is a little bit old, but it's still very good. So here we're going to use where. Okay, where. And what's the condition here? So the condition, it's the title to be equals Toy Story, right? So we're going to use where title, okay, title, sorry. So where title, like, and we're going to see when we use like and we want to match a specific string, we have to use this percent operator here, okay? So we're going to use like, and since it's a string, we have to start with quotation, okay? And then we're going to use percent toy, and we have to write the same way that it appears in the title here. And then we have to close with a percent here. Okay, so what this part is doing, it's grabbing all the titles that are like Toy Story and can have something after the Toy Story or before, but in this case it's after because we have number 2 and 3. So we did the first task. Now find all the movies directed by John Lasseter. I don't know how to say that, but how are we going to do this? So what's the condition now? It's the condition, it's that the director, okay, the director has to have which name. So now we're going to do it in a different way. Instead of using like, we're going to use equals. Okay, just to show you that we can use like or equals to check this condition. So if director equals to, now we have to put the name of this director, John Lasseter. Since this is a case sensitive, we have to write the name with the same way that it's appearing in the column. If we put here John in lowercase, it's not going to appear anything, okay? But when we use in uppercase, it's going to appear, okay? Now the next one, find all the movies and director not directed by John Lasseter. So here, how we're going to do, so we're going to put not like or the different operator here, right? Because with the equals, we're grabbing the director with the name John Lasseter, and if we put a difference here, we're grabbing all the other director that doesn't have this name, okay? And now we have to find all the Wall-E movies. And how are we going to do this? We can use now, so where? We're going to do the same idea as we did with Toy Story. So here we want to grab the title. The condition is the title to be like what? To be like Wall-E. and then we're going to put a percent. Okay, the percent is that this first part here has to be equals to wall, and what's after the wall can be any letter here. Okay, that's why we're grabbing these movies. So let's continue. So again, stop the video, read everything that it's written in here, and I'm going to highlight some parts after you're reading, okay? So even though the data in the database may be unique, the results of any particular query may not be any particular query may not be. So even the data in the database may be unique, the results of any particular query may not be. Take our movies table for example. Many different movies can be released the same year. In such cases, SQL provides a convenient way to discard rows that have a duplicate column value by using the distinct keyword. So here, the distinct keyword will blindly remove duplicate rows. And we will learn in the future lesson how to discard duplicate based on specific columns by using the group clause. Okay, so here it's basically explaining the distinct. Now we have another thing to learn. It's the ordering results. So to help with this, SQL provides a way to sort your results by a given column in ascending or descending order using the order by. So here we can order our results, and we can put a specific clause, and it's going to return. For example, if we wanna receive as a result a table ordered by alphabetically, we can have this, okay? Or if you want this to be sorted by the ID, we can have this using this order by, okay? We can have the limiting results to a subset. So another clause which is commonly used with the order by clause are the limit and offset clauses, which are useful optimization to indicate to the database the subset of the results you care about. The limit will reduce the number of rows to return, and the optimal offset will specify where to begin counting the number of rows from. So we have all of these things, okay? I know it seems a little bit confusing, but take a look on the problems, especially limit and offset, because they're kind of confusing. So I'm going to read this again. So the limit will reduce the number of rows to return, and the optional offset will specify where to begin counting the number of rows from, okay? So we can use a lot of information to select the query that we want. So let's see the exercise. There are a few concepts in this lesson, but all are pretty straightforward to apply. To spice things up, we've gone and scrambled the movies table for you in the exercise to better mimic what kind of data you might see in the real life. Try and use the necessary keywords and clauses introduced above in your query. So in the previous problem, this query was sorted by the year, right? But now it's all scrambled. So we have to use the information that we learned in this session and to do the exercises, okay? So let's see here. List all directors of Pixar movies alphabetically without duplicates. So here we have two things to do. Not two, actually we have to do three. We want to grab just the column of directors, okay? So this is the first thing we have to do. Then we have to order this alphabetically, and we have to take out the duplicates, okay? So for example, here we have two movies of John Lasseter, but we don't want to appear this name more than one time. So we have to take out this problem. And how are we going to prevent the duplicates? So we already saw this. We're going to use the distinct keyword, okay? So select this thing. Select this distinct director because we want to we don't want to have duplicates of directors. So here we're grabbing all the directory that appears in our table, but we have to do more than this. We have to order this alphabetically. So how are we going to do this? We're going to use order by. Okay, we have to set the column that we're going to use as standard for the order by, and then we have to set if it's ascendant or descendant. Okay, so here we're going to use select distinct director from movies, order by, and we're going to order by the directors, right, alphabetically. So directors, director, and since we want alphabetically, we want, so by default, if we put this, it already goes to, it does alphabetically, but we can use here also ASC to explain that it's ascendant. Okay, now list the last 4 Pixar movies released, ordered by the most recent to the least. So now we want to list the last 4 Pixar movies. So let's take all this out to see again our table. So now what do we want? We want to select, it doesn't explain which columns we want to select, so here we're going to use a star. Okay, from movies, so from this table here, we want to select what? The last 4 Pixar movies released. So before we limit before we set how many Pixar movies we're going to release, let's first order this from more recent to least, right? And what's going to be the column that it's going to set this condition to order? It's the year, right? The year that contains the when it was released. So we're going to order by year. But if we do this, it's going to do from the most that it's from the past up to the recent, right? But we don't want this. We want to the most recent to the least. So what we're going to do, we're going to use the desk, that is this descendant order. So here we're grabbing all the movies by their most recent to the list, but we don't want to grab all the movies. We want to grab just the last 4. And to do this, we're going to use the limit, and we're going to put a number of rows we want to return. Okay, so here we're going to put limit, since we want to limit last 4, so here it's 4. Okay, now list the first 5 Pixar movies started alphabetically. So now we already understand the idea, so we want to grab the first 5 Pixar movie. Since it doesn't specify which column, we're going to grab all, okay, using the asterisk, and we're going to now sort by alphabetical order. And what is going to be the order? What column is going to set this alphabetical order? It's the title, right? We want to put this in alphabetical order from the title. So we have here A Bug's Life, Brave, Cars, and so on and so forth. But we don't want to grab all. We want to grab the first 5, right? So here we're going to use limit 5. And perfect. List the next 5 Pixar movies sorted alphabetically. So now we want to list the next 5 Pixar movies, the next 5 after these ones. So what are the next 5 and how we're going to do this? We're going to use the offset, because the offset we will specify where to begin counting the number of rows from. So we want to grab 5 Pixar movies, but we don't want to grab the first 5. We want to grab the next first 5. That is the, for example, if we have here 10. here it's the first 5, but we want to grab the other's first 5. So how we're going to do this? We're going to use limit 5, and we're going to use the offset is starting, and the offset, what's the number that we put? We're going to specify where to begin counting the number of rows, and in here where we want to start counting on number 5. Okay, let's go to the next one. So here we have simple select queries. So again, don't forget what I said before. Do a pause and then you can play again the video just to know what I'm going to say next, okay? So we've done a great job getting to this point. Now that you've gotten a taste of how to write a basic query, you need to practice writing queries that solve actual problems. So here we're going to test if we understand the points so far, okay? So nothing new for us. So in this exercise below, you will be working with a different table. This table instead contains information about a few of the most populous cities of North America, including their population and geospatial location in the world. Try and write some queries to find information requested in the tasks you know. You may have to use a different combination of clauses in your query for each task. Once you're done, click to continue and blah blah blah. Okay? So now let's test if we learn until now. Okay? So list all the Canadian cities and their population. So how are we going to grab the Canadian cities? So in this task, we have to do two things. We have to list all the Canadian cities, and we have to list also their populations, okay? So here we're going to select what? We're going to select country, okay, because it's the Canadian cities, and population, because we want to show the country and the population. Now, what do we want to do? We have this from, that it's the table, North American cities, and now we want to grab just the Canadian. So how are we going to do this? We're going to use the where we can set a condition. And what's the condition? Country equals to Canada. Okay? So I'm sorry, we don't want to grab the country. We want to grab the city, right? Sorry, we want to grab the city and the population. So here we are defining city and population from the table, and the condition here, it's country equals Canada. Now let's go to the next one. Order all the cities in the United States by their latitude from north to south. So let's check all our query here. Okay, so we have this, we have column city, country, population, latitude, and longitude. So first thing that we're going to do is what? We're going to do, we're going to select what we're going to select. We're going to select the city, right? Because it wants to get the cities. And in the USA, so this is going to be the condition, okay? So cities in the USA, and then we're going to order all about getting the latitude from north to south. So first things first, what we want to select? We want to select the city, right? City from this table. And now we want to do what? We want to do a where, and where the cities are. The cities in the USA, so country equals United States, okay? And we want to order this by their latitude, so order by latitude from north to south. So from north to south, we're going to use the descendant thing. Do you remember here, ascendant and descendant? Because the default case, in the latitude, it grabs to south to north. But since we want to grab from north to south, we're going to use here desk. Okay? Now let's go to the next task. Let's see all the table again, okay? And list all the cities west of Chicago, order from west to east. So here we want to do what? We want to list all the cities, so we're going to grab the column cities, and we're going to, and what's the condition? It's the cities of west of Chicago, okay? So we're going to do a condition inside another condition, okay? And then we're going to order by west to east, sorry. We're going to order by west to east. So here, what's the column that we want? We want cities, okay, from blah, blah, blah. And what's the condition here? The condition we're going to use to get Chicago, we're going to use the longitude, okay? So the longitude has to be less than, and inside of this parenthesis, we're going to put the condition that we want. So we want the condition to be what? We want to select here, select longitude, okay, from North American cities, we have to specify here again, and where city is equals to Chicago. I know it seems confusing, but what Chicago? So what are we doing here? We're grabbing this inner select from where, it's setting that we have here Chicago, okay, and the outer where, we're saying what? That we want to grab the cities in west of Chicago, okay? That's why the longitude has to be less than the longitude of Chicago, okay? And then we have to order this by what? Order from west to east. So we're going to order by the longitude again, okay? I know it seems confusing, but it's kind of, in here we are defining Chicago, and in here we are defining the condition that has to be cities west of Chicago, okay? So let's continue. Here we have our full table. So now list the two largest cities in Mexico by population. So how are we going to do this? We want to grab the two cities, so this is the column, okay, city, from North American cities, and what is the condition here? The cities of Mexico, right? So where, it's what? Country, it's equals to Mexico, okay, because we want to grab the cities in Mexico, but we want to grab the two largest. So first, let's work with the largest. How are we going to grab the largest? We're going to order by the population, okay? So order by population. But if we put here population, I'm going to show you population. If we put here population, it's ordered by the one that has less population to the one that has the largest population. But we want the two largest cities, so here we want to be descendant, okay? So we see here that now we have Mexico City first. And we just want to grab the two largest cities. So I'm going to erase here population. I just create this column to show you. And now, since we want the two largest, we're going to use limit 2, okay? And perfect. And now let's see the last task. Let me show all the table again. And list the third and fourth largest city by population in the United States and their population. So here we have a lot of things to do, right? So let's step into this problem. So we're going to list the third and fourth largest city. So we're going to grab the third and the fourth largest city by population, okay, in the United States and their population. So here we're going to show the city and their population, okay, because we want to list cities and population. So in the select, what we're going to do, we're going to put city and population because it's what the task wants us to show. And what's the where condition? It's United States, okay? We want to grab the third and the fourth largest cities in the United States. So where country is equals to United States, right? And we want to grab just the two. We want to grab the third and the fourth largest cities. But here it's not sorted, right? It's scrambled. We have different values of population in here. So a nice thing to do this is sort this query by population. So do an order by population. But since we want to grab the largest, we're going to do a descendant order here, okay? So we're grabbing here, this is the largest, this is the second largest, this is the third largest, and this is the fourth largest. So since we want to grab just these two cities, we're going to put here limit 2. But if we use here limit 2, we're grabbing the two largest cities in USA. It's not the third and the fourth, it's the first and the second. So in order to grab the third and the second, we're going to use offset, okay? So offset 2. And then we're done with this problem, that it's Chicago and Houston, okay? So now let's do this lesson. So we have here, remember, stop the video to read, okay? We have database normalization, we have multiple table queries with join. This is the part that we're going to take a look, okay? So tables that share information about a single entity need to have a primary key that identifies that entity uniquely across the database. Normally we use the ID. So one common primary key type is an auto-incrementing integer because they are space efficient. But it can also be a string hashed value so long as it is unique. Using the join clause in a query, we can combine raw data across two separate tables using this unique key. The first of the joins that we will introduce is the inner join. So here we have what? We want to select a query with inner join on multiple tables. So we are going to do the select, the from, and the difference here, it's what? We're going to put an inner join, and we're going to write the name of another table. On, in the on, we have to put what the primary key that makes the two informations in these two tables the same, and then we can do the rest. So the inner join is a process that matches row with the first table and the second table, which have the same key, as defined by the on constraint, to create a result row with the combined columns from both tables. After the tables are joined, the other clauses we've learned previously are then applied. So let's put here SQL join query. Okay, and let's see some images, and I think it can understand better. So what's the inner join? The inner join is this case here where we're going to grab the informations that we have here that both table A and B have the same, okay? So that's what we're going to do in this case. So the exercise is, we have added, let me just check if I'm recording. So we have added a new table to the Pixar database so that you can try practicing some joins. The box office table stores information about the rating and sales of each particular Pixar movie, and the movie ID column in the table corresponds with the ID column in the movies. table 1 to 1. So this movie ID and the ID, it's the primary key that matches in both tables, okay? So try it and solve the tasks below using the inner join introduced above. So here we have the query, the table that we already saw before, okay, in the previous problems. And here we have a new table that has the movie ID, and the movie ID, it's the same as the ID here. So these two are the primary keys that it's going to match in both of these tables, okay? We have the rating, the domestic sales, and international sales. Okay, so now our problem is going to be to do this inner join. So let's start. Find the domestic and international sales for each movie. So first thing that we're going to do is what? We want to grab the domestic and international sales that it's in here in the table box office, and we want to grab this domestic and international sales for each movie, and each movie has this title in the movie table, okay? So here we're going to do an inner join of these two tables, okay? So what we're going to do first, so we want to select what? The title, right? The domestic sales, it's the name here, and the international sales, okay? And we want to grab this from movies, but we have to set the inner join, and here it's the way that we use the inner join. So remember, we have to put inner join, the name of the another table, okay, and we have to put which column matches in these both tables here. So that's what we're going to do. So here, inner join, okay. And what's the name of the other table that we're grabbing? It's what? It's box office, okay. So here we're going to put box office. And what's the primary key? What's the columns that both of them have the same? It's ID and movies ID. So that's how we're going to match the both columns here. So on movies.id. So why we put movies.id? Movies is the name of the table and ID is the name of the column. So movies.id, it's equals to what? Box office.movie ID. Box office.movie ID. So now it matches, okay? We know the title and we have the domestic sales and international sales. Now let's go to the next one. Show the sales number for each movie that did better internationally rather than domestically. So the idea is basically the same. We're going to grab the movies, okay? We can put here all the informations of the movie because it doesn't specify what it wants to appear. So here we're grabbing all. In this table here, what do we have? We have these two tables together, okay? So this is our query result. But we want to show only the movies that the sales numbers did better internationally rather than domestically. And how are we going to do this? We're going to use the where. And the where is what? The where set the condition that we want. So where international sales is greater than domestic sales. Okay? Let me see if I put international sales. Okay, so we did this task, right? And now list all the movies by their rating in descendant order. So here it's going to be the same, okay? So we're going to do an inner join again, but now we're going to list all the movies by their rating in descendant order. So since we want to list all the movies by their rating, we want to show the title, okay, and the rating, title and ratings, and what? Where it's rating. It's rating in this case. The name of the column, it's rating, okay? It's not ratings. That's why it's not finding here. So rating. And we want to order this by descending order of rating. So here we're going to do what? We're going to use order by, okay? So we're putting more information in our query. So ordering by rating and descending, so desk, okay? Let's go to the next one. So now we're going to work with outer join. And let me show you outer join here. So this is the inner join, okay, we already saw. And now the outer join, it's what? It's this idea here, okay, when we're grabbing all two tables, okay, and that's the idea when we're grabbing all the information in here. So let's see. Depending on how you want to analyze the data, the inner join we use last lesson might not be sufficient because the resulting table only contains data that belongs in both of the tables. If the two tables have asymmetric data, which can easily happen when data is entered in different stages, then we would have to use a left join, right join, or full join, instead to ensure that the data you need is not left out of the results. So we have all of these cases of SQL joins, okay? This is the left join, the right join, and another cases of left and right join, and this is the outer join, okay? So we can have a table that only contains information that both of the tables have, or we can have all of these cases here, okay? So take a look on this later. So to do this, we're going to do exactly the same way. We're going to, instead of using inner, we can use left, right, or full join. And we have to put again the on, that it's going to say which column on table 1 it's equals to the column of the table 2. And then we're going to do the same, okay? So like the inner join, these 3 new joins have to specify which column to join the data on. When joining data table A to table B, a left join simply includes rows from A regardless of whether a matching row is found in B. So this is the left join, okay? We're going to add information of A in B. Then we have the right join, that it's the opposite for the keeps row in B regardless whether a match is found in A. And finally, a full join simply means that rows from both tables are kept regardless of whether a matching row exists in the other table, okay? So later take a look on this information. So the exercises. In this exercise, you're going to be working with a new table which stores fictional data about employees in the film studio and their assigned office buildings. Some of the buildings are new, so they don't have any employees in them yet, but we need to find some information about them regardless, okay? So since our browser SQL database is somewhat limited, only the left join is supported in this exercise, okay? So the left join that we're going to use, we're going to grab this table here and we're going to do a left join with this building name, okay? So we have here the building table and we have here the employees table, okay? So find the list of all buildings that have employees. So here our main table, it's what? It's the employees, okay? So find the list of all buildings that have employees. So here we're going to find the list of all buildings that have employees. So we're going to select the building name, okay? Building name. But as we can see here, the building, actually it's not building name. The name of the column, it's building. So the building here, it's what? We have here, it's appearing more than one time, the same name of building. So here we're going to use the distinct, okay? That we already saw. So here we're just going to show 2 buildings. So this is the first case. Now the next one. Find the list of all buildings and their capacity. So here we're going to find the list of all buildings and their capacity. So here we're going to put star, and we want to see all buildings and their capacity. Here we have the building name and the capacity, so we're just going to show the table building. Okay, so instead of employees, we're going to put here buildings. Okay, so here we're just showing the second the table buildings. And now let's see here. So list all buildings and the distinct employee roles in each building, including empty buildings. So now we're going to do what? We're going to do the left join, okay? So since we want to do a left join, we're going to grab this table and we're going to grab information from this table. Why? Because we're gonna list all the buildings, okay? And we want to grab the distinct employee roles, okay? That is here, that is in the table employees. So what we want to show? We want to show the building, right? We want to put the building name and what? And we want to show the role, okay? But role, it's not in this table, it's not in buildings table, so we're going to do a left join. So left join, and what's the name of the table in left join? It's employees, so employees, okay? And we want to show, and we have to put the information that sets the primary key, okay? Which columns matches in each table. So building name matches with building here, okay? So that's what we're going to show. So on building dot, so buildings, okay, it's the name of the table. So building name, that it's the name of the column, so buildings dot building name, it's equals to what? It's equals to employees building dot building, okay? It's equals to employees dot building. Okay, so by now we're setting all the information that we want. We list all buildings and the distinct employee roles in each building. But we are setting this not in a distinct way because it's appearing a lot of times here. The building name 1E and the role engineer. So what we're going to do, we're going to use here distinct, okay? And that's what we have. So we know in building 1E we have engineer and manager. In 1W we have no employees. In 2E we have no employees. In 2W we have artist and manager, okay? So let's go to the next one. So a short note on no's. So sometimes it's also not possible to avoid no values, as we saw in the last lesson when outer joining two tables with asymmetric data. In this case, you can test a column for no values in a where clause by using either the is no or is not no constraint. So in the where we can use is or is not no. It's one more condition that we can use, okay? So we're going to work on that. And we're going to keep working with join tables, join queries. So this exercise will be a short review of the last few lessons. We're using the same employees and buildings table from the last lesson, but we've hired a few more people who haven't yet been assigned a building. So here we have some employees that they are not assigned to some buildings, to their building, okay? So let's do the problem. Find the name and role of all employees who have not been assigned to a building. So this first here, we have the employees table and we want to grab the name and the role of all employees who have not been assigned. So we want to grab the name and the role from employees And what? Where? What's the condition? Where they are not assigned to a building. So where building is no, okay? We just need to use the employees table. So where building, the column building is no. So where building is no. So these two employees here are not assigned to a building. Now find the names of the building that hold no employees. So now we're going to check in here. We're going to check the name of the buildings that hold no employees, okay? So how are we going to do this? We're going to use the left, we're going to grab here. So we're going to select all, okay? And we want to do what? Let me erase here. We want to grab what? We want to grab the buildings that hold no employees. So let's use the buildings table. So buildings, okay. And what's the buildings? We want to find the names of the buildings that hold no employees. And how we're going to check these no employees inside? We're going to match with this employees table to check where each employees work, and check if any of this building name has no employees, okay? So how are we going to do this? We have to use the left join, and we're going to do a left join within. Actually, it's the opposite. No, it's true. It's right. Employees. Okay. We have to explain the primary key. Okay, so building name. It's equals to what? Employees dot building. Okay, so I think it's buildings. Okay, so here we are setting, we did the left join, so here we have all matched. And now we have to check the building that holds no employee. So we're going to check what? We're going to check where role. Why role? Let me erase this. So why role? We can use role because role here it's empty. We can use name because name it's another field that it's empty, or building, or years employed. You can use any of these 4 columns here to set the is no, to check if the building holds no employees. So where I'm going to use role is no. Okay, and we can grab this. We can use role is no, or name is no, or building is no, or years employed. And why we can do this? Because these 4 columns here has no value, it's empty. Okay, let's go to the next one. So query with expressions. In addition to querying and referencing raw column with data with SQL, you can also use expressions to write more complex logic on column values in the query. These expressions can use mathematical and string functions along with basic arithmetic to transform values when the query is executed, as shown in the physics example. So for example, here we can put select the particle speed divided by 2 as half particle speed from physics data, where we can use see here that in each database has its own supported set of mathematical string and data function that can be used in query, which you can find in their own respective docs. The use of expressions can save time and extra post-processing of the result data, but can also make the query harder to read. So we recommend that when expression are used in the select part of the query, that they are also given a descriptive alias using the as keyword. So we can do this as we can use the as this as keyword to say what? We can do this thing here. We can divide one column, the values of one column by 2, and we can set these new values in one column with this name. Okay, so the as here, it's to set the values that we are doing the select to a new column that we're creating. So the idea here is that we can manipulate the data like we do when we are programming Python and C. We can use division, multiplication, and all other mathematical and string and date functions, okay? Depending on the information of your column. So that's what we're going to do in this case. So you're going to have to use expressions to transform the box office data into something easier to understand for the tasks below. So here we have movies table, okay? We are back to the movies and the box office table. And now let's see the tasks. So list all movies and their combined sales in millions of dollars. So let's do first thing first. We want to do what? We want to do a list of all movies, okay? And we want to combine sales in millions of dollars. So first we have to think that we are doing here an inner join, right? Because we want to list the movies and we want to check their sales. So let's do this first. So we want to put here what? We want to put, by now I'm going to put a star, okay? So let's do the inner join. So inner join, and what's the table that we're doing the inner join? It's the box office, okay? And now let's put the primary key that is going to match the both tables. So on, what's the name of the table? It's movies.id. It's equals to box office dot, what's the column? Movie ID. Movie ID. So here we're first doing the inner join, okay? Now what do we have to do? We have to grab the title and the sale and their combined sales in millions of dollars. So what are we going to do in this case? We're going to grab the movie, so title, right? And we want to grab the combined sales in millions of dollars. So what's the combined sales? We have to sum these two columns, so the value of these two columns here, and we're going to share as one column only. So we're going to put here. Let's check how it goes. So first we put the operation that we want to set, and then we use as, and then we put a name for this new column. So we're going to do this, okay? So we're going to do what? We're going to add domestic sales with international sales, okay? And you see that this is the name that it's appearing, but it's not a good name to set. So we're going to put as sales, okay? So now appears here as sales. But we want to set their sales, their combined sales in millions. So we have to divide this by a million, okay? And a million has 6 zeros. Perfect. So we did the first part. Okay, this is the first problem, the first task. List all movies and their rating in percent. So we're going to keep using the inner join, so we don't need to do this again, okay? And now we're going to manipulate the rating, right? So we want to set all movies, so I'm going to put here title. And we're going to set the ratings in percent. We have here the rating in a number from 0 to 10, but now we're going to transform in percent. And how we're going to do this? We're going to multiply by 10, okay? So let's put this in here. We're going to put rating. What we're going to do? Rating multiplied by 10, okay? But you see that this is the name of the column, so since we don't want to have this name, we're going to put S ratings %, okay? This is just to make things more pretty. It already said to us this task is okay, but I'm explaining to you this S thing here. Now list all movies that were released on even number years. So now we're going to work with this operation not in the select but in the where, and we see here that we can use the operations in the select or in the where. Okay, so that's what we're going to do. So let me take out of this. So since we want to list all movies, we're going to list the title and the year, okay? And we're going to do the inner join. It's so far so good. But now we're going to work with the where condition. And what's this condition? Where the year, it's an even number. And what is an even number? It's a number that every time that you make a division by 2, the remainder is 0, right? We already saw this in previous problems in programming, so I highly recommend you to check our videos explaining basic C language and Python. So the even number, it's going to set as well. So year, this is module, so the module represents a remainder. So what is this? When we do a division, this is going to set the remainder of this division. So if the remainder of the division by 2 is equal to 0, it's an even number, okay? And this is it. Let's continue. So query with aggregates. I don't know how to say that, aggregates. So in addition to the simple expression that we introduced last lesson, SQL also supports the use of aggregates, expressions, or functions that allows you to summarize information about a group of rows of data. With the Pixar database that you've been using, aggregates, I can't stop laughing every time I said this word. So leave on the comments how should I say that, okay? Functions can be used to answer questions like how many movies has Pixar produced, or what is the highest grossing Pixar film each year. So this aggregate function, it's going to set the same way as the operations, okay? But the aggregate function already has some meaning. It's like in programming, for example, in Python, when we use abs, we know that we're grabbing an absolute value. Or when we use min, we know that this function will return us the minimum value. So we have the same idea here on queries, okay? So common aggregate functions, we have count, a common function used to count the number of rows in the group if no column name is specified, otherwise count the number of rows with no values in the specified column. We have the min to find the smallest numerical value, the max that finds the largest numerical value in a specific column, the AVG that finds the average numerical value in a specific column for all rows in the group, and the sum that gets the sum of its values in the specific column, okay? These are the most common, but you can see in the SQL tutorial in Double3 Schools that we have much more functions, okay? Or you can click in these pages here, and we have the grouped aggregate functions. In addition to aggregating across all the rows, you can instead apply the aggregate function to individual groups of data within that group. This would then create as many results as there are unique groups defined as by group clause. So this is the idea. Basically, we're going to use aggregate function, okay? The group by clause works by grouping rows that have the same value in this column specified. So group by, it's going to rearrange, it's going to group the rows that have the same value in the column specified. It works like the ordered by, okay, but it's going to group the information. So for this exercise, we're going to work with our employees table. Notice how the rows in the table have shared data, which will give us an opportunity to use aggregate functions to summarize some high-level metrics about the teams. Go ahead and give it a shot, okay? So now we have just one table here, okay? And let's see, find the longest time that an employee has been at the studio. So if we see here the longest time, what aggregate function we can use? The maximum value, right? Because it will return to us the maximum value in the specific column for all rows in the group. So we're gonna do what? We wanna select the maximum value of what? The person that has the longest time that an employee has been in a studio. So we're going to work with the years employed, okay? So the maximum value, it's this, okay? Now we're going to do the next one. For each role, find the average number of years employed by employees in that role. So to grab the average number of years employed by employees in that role, we're going to use what? We're going to use the average value, okay, AVG here, AVG. So here we're grabbing the average value. And what we can do, we can set this as, we can give a name, average years employed, okay? We can set the name of the column like we did when we were using operators in the previous lesson. But we want to check for each role. So we have to set here role, okay? And we have to group by roles. We don't want to grab the average value of just one. We want to grab the average value for each role. So that's why we're going to use group by what? By role, okay? That's the idea. We're grouping the information in artist, engineer, and manager. There are the three roles that we have in our table. Now find the total number of employee years worked in each building. So since we want to grab the total number, what we're going to use? The sum, right? So let me just refresh our table to set everything, okay? So we have here everything. Now we have to find the total number of employee years worked in each building. So we have here some cases. First, we have to grab the building, okay, because we want to see the building and the total number of employees. So the total number we're going to grab with the sum aggregate function. And then we have to do the group by to grab the total number of each building, right? So that's what we're going to do. So we're going to select building, okay, and the sum of the years that the person employed. So years employed, okay, and we're going to set here as sum total employee total years employed, okay. But here we're just showing one, right? But we want to show all buildings. Here we're just showing the building 2W, but we want to show all buildings, so we're going to use group by building, okay? And that's it. Let's go to the next one. So queries with aggregates part 2. Let me check if I'm recording. Okay, so far so good. So our queries are getting fairly complex, but we have nearly introduced all the important parts of select query. One thing that you might have noticed is that if the group by clause is executed after the where clause, which filters the row which are to be grouped, then how exactly do we filter the grouped rows? Luckily, SQL allows us to do this by adding an additional having clause, which is used especially with the group by clause to allow us to filter grouped rows from the result set. So the idea here is that we can group by here, and we can use this having clause to specify which is used specifically with the group by clause to allows us to filter grouped rows from the result set. Okay, so then you can read this later, but let's do this part. We have again the employees data. Okay, and we're going to work with this task. So find the number of artists in the studio without a having clause. So since we want to find the number of artists in the studio, we're going to use the count aggregate function that we had before. So here we're going to put count the number of artists, so count roll. Okay, I'm going to put here as number of artists. Okay, but this is not showing the number of artists that we have. We have to do what? Sorry, my cat just went really crazy here in my bedroom, but it's okay. So here we're counting the row, but we're not specifying which row we want to check. So here we have to put the condition where row is equals to what? To artist. Okay, so it's showing just 5. Now find the number of employees of each role in the studio. So here we're going to find the number of employees on each role in the studio. So instead of where here, we're going to put what? We're going to group by role, right? So here we're showing this, but it's good to put the role also to see the role. Okay, so we're seeing the role and the number of artists in each row. Actually, number of people, employees in this case. And now find the total number of years employed by all engineers. So now we have a specific case, a different case. So let me erase here because we're going to do a different problem now. Let me erase here. So find the total number of years employed by all engineers. So what is when we see total number, we remember what? The sum aggregate function, right? So we're going to put here, we want to get the role and the sum of total numbers of years. So here we're going to use years employed. Okay, but in this case it's grabbing a default role, it's grabbing manager, but we don't want to check manager, we want to check the engineers. And how are we going to do this? So first we have to use the group. Okay, so group by role, but now it's setting all the roles. Okay, and what we're going to use? We're going to use the having, that we can put here a group condition. So what's our group condition? Having role equals what? We want to set all engineers. So here set engineers. We have to put with upper E, engineers. And why it's not appearing? So let me check. Let me take out this having. Okay, it's not engineers, it's engineer in the singular. Oops. So let me take out the S here, and it's appearing here. Okay, so by now, so far, so good. It's good for you to see me doing some mistakes sometimes, because it's nice to get this idea, okay, of, oh, I had some trouble here, so how am I gonna make this right? And then you're actually learning when I do things wrong also, okay? So now order and execution of query. Now that we have an idea of all the parts of a query, we can now talk about how they all fit together in the context of a complete query. So this is everything that we learned so far. Okay, we learned a lot of things. So great work for us, congratulations for us. And now let's see the query order of execution. So the first thing we have to do is the from and the joins, okay? The from and the joins. Then we go to the where to set the condition. Then we put the group by, then the having, then the select, the distinct. Actually, it's good for you to read this very calm later, okay? But the idea is basically to follow this sequence here, okay? So select, from, join, on, where, group by, having, order by, limit, and offset. And the things you're not going to use, you just delete. So for example, I'm not going to use join table. So you have to follow this idea here, okay? So always have this path in mind because this is how all fit together, okay? Then you can read this later to understand better. So the conclusion is not every query needs to have all the parts listed above, but put a part of why SQL is so flexible is that it allows developers and data analysts to quick manipulate data without having to write additional code, all just by using the above clauses. Okay, so now let's go here. Here ends our lesson of select queries. Congrats of making it this far. This exercise will try and test your understanding of queries, so don't be discouraged if you find them challenging. Just try your best, okay? But we're going to do this problem, I am sure. We have two tasks here. So in this table we have movies, and in the next table we have box office, okay? So find the number of movies each director has directed. So here, what we have to do, we're going to grab the number of movies and the director, right? So what we're going to do, we want to find the number of movies each director has directed. So here it's kind of simple. We're just going to use the movies query, right? We don't need the box office, so we're not going to do any join. So select here, what we're going to select. We're going to select the director, okay? And what? We want to find the number of all movies each director has directed. So when we see all or the total, we remember what? The sum aggregate function. So we're going to sum, we're going to count actually, okay? We want to count each what each director did. So we're going to count everything in this case as default. I'm going to put here as I don't know, movies, director, movies, okay? And now we have to group this by the director, right? To show the all directors and the count of movies that the director did. So here we're going to put group by director, okay? So now we can see each director and how many movies they did. Now let's go to the next one. Find the total domestic and international sales that can be attributed to each director. So here it's basically the same idea, but instead of counting the movies, we're going to find the total domestic and international sales, okay? So as we can see here, total, we remember what? Sum, okay? But what we're going to sum? We're going to sum the domestic and international sales. So domestic sales plus international sales. So we're summing the values of these two columns here, but we're by now just using the movies table, so we have to do the inner join here, okay? So we're going to do from movies, right? And we have to do the inner join. So inner join box office, right? And what's the primary key? It's movies.id. It's equals to box office.movie.id. Okay? And we're done to these tasks. Great job for us. Now we stop working with select and now we're going to use inserting, okay? So we've spent quite a few lessons on how to query for data in database, so it's time to start learning a bit about SQL schemas and how to add new data, okay? So the select is more about manipulating the information that you already have on the table, and now the inserting row and the delete row, we're going to, and other information that we can use. It's more about changing the database, okay? The select, we were just working with what we're going to see, and now we're going to work with the database itself. So what is a schema? We previously described a table in a database as a two-dimensional set of rows and columns, with the column being the property and the rows being instance of the entity in the table. In SQL, the database schema is what describes the structure of each table and the data types that each column of the data can contain. So later you can read this better, but now we're going to work with the idea of inserting new data. When inserting data into a database, we need to use an insert statement which declares which table to write into, the columns or data that we're filling, and one or more rows of data to insert. In general, each row of data you insert should contain values for every corresponding column in the table. You can insert multiple rows at a time by just listing them sequentially. So here we can insert, and here we have to say, so insert in the table these values, okay? Or we can put insert the name of the columns and the values, okay? So that's the idea basically. So for example, box office, we already saw this box office table before in the exercises. Here we have the name of the columns, and if you want to insert a new row, we can do this. We use insert, the columns, and the values of these columns, okay? So in this exercise, we're going to play Studio, Executive, and add a few movies to our portfolio. In this table, the ID is an auto-incrementing integer, so you can try inserting a row with only the other columns defined. So we don't need to insert the ID because ID it's auto-incrementing, so we just need to insert, for example, title, director, year, or length, minutes, okay? So since the following lessons will modify the database, you have to manually run each query once they are ready to go. So here we have, add the studio's new production, Toy Story 4 to the list of movies. You can use any director. So let's do this. So we know that we have to use insert into the name of the table, and then we have to put the name of the columns and the values of each corresponding column, okay? So we wanna insert a new production to the list of movies, and we can use any director. So here we're going to use what? So it's insert into movies, that it's the query that we're working, okay? Insert in movies, what? We're going to put here. We're going to insert title, director. We're going to grab each column of here. So title, director, year, and length, minutes, minutes. What we're going to insert, now we put here values, so values, this is the structure, okay? Insert into the name of the table, the columns, and now we're going to insert the values. And what are the values here? We're going to insert Toy Story 4, okay? I'm going to put the director the same as the other Toy Story, so John Lasseter. I'm gonna put year as 2019. I think this was the year that it was released. And length minutes will be what? Will be, I don't know, 100, okay? And now we have to close with the semicolon. So let's see, we're using everything right. So insert into movies, title, director, year, length of blah blah blah, values, Toy Story, blah 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 blah. And why it's not appearing? So we have to click here, run query. So far so good. We inserted here Toy Story 4, okay? Now Toy Story 4 has been released to critical acclaim. It had a rating of 8.7 and made 340 million domestically and 270 million internationally. Add a record to the box office table. So let's do this. Toy Story 4 has been released to critical acclaim, so we're going to put this information here inside. So insert into, okay, and now we're going to manipulate box office. And what values we're going to insert? So here we have to insert the movie ID, okay, because in order to make this table matches with this in the future with the inner join, we have to put the movie ID the same as we have the movie ID in here, okay? So we're going to put movie ID, rating, we're going to put all the columns that we have here inside. Domestic sales and international sales. And what values we're going to put? We're going to put in movies ID, we have to put the same ID as in here, so it's 15. The rating is 8.7. The domestic sales it's 340 million, and the international sales, we don't need to write international sales. International sales is 270 million. Okay, now we have to put a semicolon and run the query. And all correct. Okay, it's inserted in here. So let's continue. Updating rows. So in addition to adding new data, a common task is to update existing data, which can be done using update statement. Similar to insert statement, you have to specify exactly which table, columns, and rows to update. In addition, the data you are updating has to match the data type of the column in the table schema. So for example, if you want to change one value in the column, we have to use the update, set, and the where condition, okay? The statement works by taking multiple column values paired and applying those changes to each and every row that satisfy the constraint in the where clause. Okay, so we have the taking care. Most people working with SQL will make mistakes updating data at one point or another, whether it's updating the wrong set of rows in production database or accidentally leaving out the where clause, which causes the update to apply to all rows. You need to be extra careful when constructing update statements, okay? So one helpful tip is to always write the constraint first and test it in a select query to make sure you are updating the right rows, and only then writing the column values pairs to update. So that's what we're going to do. We're going to work again with the movies, and we're going to change something. So the director for A Bug's Life is incorrect. It was actually directed by John Lasseter. So we're going to do the taking care. First, we're going to select the information, and then we're going to use the update. So select director from movies, and we're going to set the condition where, what's the condition? Where title equals to what? Equals to to A Bug's Life. So let's check if we grab the right condition. Since here we can see that we have a single quotation mark in here, we're going to use double quotations to don't have this mistake, okay? So when we check, so run query, when we check, we get here the director from this movie. Let me put here title and director. Let me run again. So when we use here, we see that we're grabbing the movie A Bug's Life, and we have here director set as L director, but we want to change this information. So we're going to use what? We're going now to use the update. So let's see here. We have the update. We have to put the name of the table, set column equals value or expression, other column blah blah blah, and the condition. So here we're going to put update, okay, movies. We don't have from because we're calling the update, and we're going to set director, okay, equals to, we're going to change the director from A Bug's Life to John Lasseter. And what is the where? The where is where title is A Bug's Life, okay? So we know that we're selecting the right thing, and then we're going to run the query, and it's updated. So now A Bug's Life has this director here. The year of Toy Story 2, let me just check if I'm recording. Okay, so the year that Toy Story 2 was released is incorrect. It was actually released in 1999. So we're going to do the same thing. So select all, okay, from movies. It's always good for us to take this care, okay? And what's the condition? We're going to grab what? Toy Story 2. So we're going to where title equals to Toy Story 2. Okay, so what we grab? We're grabbing this. So we know that the ID is what? Is 2, right? So we're grabbing this information here. So let's work with this information. We know that where title it's this. So now we're going to update this incorrect information. So let's now do the update. So update what? Movies, okay. Set what? Set year equals to 1999, right? And then where title it's this one. So let's run the query, and now we're set the right year. Now both the title and director for Toy Story 8 is incorrect. The title should be Toy Story 3, and it was directed by Lee Unkrich. So let's first select all from movies. We're taking care here, okay, where so what's our where here? Since we're going to change the title and the director, let's check the ID of Toy Story 8. So the ID of Toy Story 8, it's 11. So here we're going to put ID equals 11, okay? So let's check if we find the information. So we're finding the information. Now we have to change the title and the director, and now we're going to use the update movies, it's the name of the table, and we're going to set what? We're going to set title equals to Toy Story 3, right? And what's the other information we're going to change? Director equals to what? Lee Unkrich. Then we're going to put where ID it's 11, okay? Because we know that this is the right ID. And now we run the query, and now it's all good. Okay, so let's continue. Deleting rows. So when you need to delete data from a table in the database, you can use a delete statement, which describes the table to act on and the rows of the table to delete through the where clause. So the idea is basically the same. We're going to delete from the table the condition. So here again, the extra care is like the update, okay? And here, if you decide to leave out the where constraint, the all row are removed, which is a quick and easy way to clear out a table completely. If intentional. If it's not intentional, I'm not going to say the word because it's a bad word. So now let's do the database needs to be cleaned up a little bit. So try and delete and fill rows in the task below. So this database is getting too big. Let's remove all movies were released before 2005. So first let's do the careful way. So we're going to do where year it's before 2005. So let's check if we grab these informations. So we're grabbing here. Now we're going to use the delete. So the form of delete is delete from the name of the table and the condition. So delete, we're going to use here delete from movies where the condition is year is less than 2005, and we clear the database. Okay, now Andrew Staton has also left the studio, so please remove all movies directed by him. So let's do here select to check first, okay, if we're deleting the right informations. And what's the where condition? Director is equals to Andrew Staton, right? This is the condition that we want to delete. So let's check. So we're grabbing here the right problem. So here we're going to use delete from movies, and we're going to delete this information, okay? So now let's go to creating tables. When you have a new entities and relationships to store in your database, you can create a new database table using the create table. So the create table, it's basically the same idea of inserting table, okay? So create table, if not exists, we put the name of the table, then we put the name of the columns, and then we can put the value, okay? So the data types, let's see the table data type. So later you can check this better, but if we check here, we have basically the same data types that we have when programming in other languages. So we have integer, boolean, float, double, real, characters, var characters. They have a difference here, text, date, time, and blob. Okay, so finally SQL can store binary data in blobs right in the database. I think this one here I haven't seen before, so this is new for me, but the others I think we just saw before. And we have the table constraints. So we have the primary key, that's the ID, for example, out increment, unique, not null, check, foreign key. So take a look on these tables. Okay, so pause the video and take a close look on this, and then do the play again, and let's read this example. So here's an example schema for the movies table that we've been using in the lessons up to now. So for example, if we want to create a new table, we write create table, the name of the table that we want, then we put here what? We put the name of the column, the type of the data, and then the constraint, the table constraint. So ID, it's an integer and a primary key. The title, the column title, it's a text, and we didn't put any constraint here. The director column, it's a text, the year, it's an integer, and the length, minutes, is another integer. So in this exercise, you need to create a new table for us to insert some new rows into. So let's create our table, okay? So create a new table, name the database with the following columns. Name, a string text describing the name of the database. version, a number, floating point of the latest version of the database, and download count, an integer count of the numbers of times this database was downloaded. This table has no constraints. So let's do our problem. So remember here, the structure is what? We have to put create table and the name of the table first. So create table, okay. And what's the name of the table? We want to put the name as database, so database. Now we open and close a parenthesis and we're going to write inside the parenthesis. Don't forget to put the semicolon. So now we're going to set the name of the column and we're going to put the data type and then the constraint if it exists. So the first thing we're going to do is the name. So name, it will be the name of the column. And what type is this? So it's a string text. So as we can see here, we're going to put text here, okay? Then, since we're going to create a new column, we use a comma and we're going to write in the next line. So we're going to create a version, okay? And what type is the version? It's a floating point. So floating, it's one type, that it's float, okay? It's the data type is float. So here we're going to put float. And the next one, it's download count. And what type is download count? It's an integer, okay? And after all, we have to put, we don't need to close with a comma, and we can run the query. Okay, so far, so good. Altering tables. So as your data changes over time, SQL provides a way for you to update your corresponding tables and data schemes by using the alter table statement to add, remove, or modify columns and table constraints. So here, let's see the first thing. So adding columns. The syntax for adding a new column is similar to the syntax when creating new rows in the create table statement. You need to specify the data type of the column along with any potential table constraints and default values to be applied to both existing and new rows. In some databases like MySQL, you can even specify where to insert a new column using the first or after clauses, though this is not a standard feature. So altering table to add new column. So we use alter table, the name of the table, and we can put add the column, blah, 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 and a default value, for example. Removing columns, it's the same idea, but we're going to use the drop, okay? So dropping columns is as easy as specifying the column to drop. However, some databases don't support this feature, okay? Renaming the table, we're going to use rename to, and other changes that you can see clicking on these links, okay? So let's do the exercise. Add a column named aspect ratio with a float data type to store the aspect ratio each movie has released on. So here we're saying add a column named so what we're going to do, we're going to add a new column. So we're going to use this add thing here, okay? So let's do what? Let's put here alter table. Alter is another word that I don't know how to say, so you can leave on the description how can I say this. And we're going to use this add. This is the convention, okay? Alter table, alter. I think it's alter table, right? Alter of altering. Yeah, I think it's alter. I don't know. Maybe I am just saying something wrong again. So we're going to add what? We're going to add. Now we're going to put the name of our column, that it's aspect ratio. And then we have to specify the data type, that it's a float, okay? And then we're done. So let's run the query, and we added here a new column. Now add another column named language with a text data type to store the language that the movie was released in. Ensure that the default for this language is English. So we're going to do the same. We're going to add, but now we're going to include this default case here, okay? So let's do the same thing. So author I don't know how to say that. Author table movies, okay? Add its language, the name of the column that we want, and the type is text. And what's the default case? So default, it's what? It's English, okay? And we're going to create a new column with all English. And now the last lesson, dropping tables. In some rare cases, you may want to remove an entire table including all of int's data and metadata. And to do so, you can use the drop data statement, which differs from the delete statement in that it also removes the table schema from the database entirely. So if we want to drop a table, we're going to use drop table if exists and the name of the table. So we reached the end of our course, so let's clean up by removing all the tables we worked with. So we've sadly reached the end of our lesson. Let's clean up by removing the movies table. So how do we do that? We're going to use this notation here. So drop table if exists, and what's the name of the table? Movies, okay? So we're going to drop first this movies table, and we dropped, okay? So now we have nothing in the database. And now we're going to drop table if exists, and what's the name of the other? It's box office. And now we are dropping the database, and now we have nothing, okay? So let's continue, and perfect, we finished the tutorial. Now I think you're going to be more confident to do the problems, okay? So now you can say that you learn another language, and this language is SQL, okay? So if you enjoy this content, please give us a thumbs up, and also if you have any doubts, you can leave on the comments, okay? I hope you enjoy this content, and see you in the next video. Bye bye.